Welcome everyone. This is lecture number 3, class 12th, chapter number 2, solutions. So let us see, this is a very small lecture. Uh, so here we see that the first part is define what is molarity. So how do we define molarity? So that's the first question. So it is defined as the number of moles of a solute dissolved in 1 liter or 1 decimeter cube of a solution, and it is a function of temperature. That is the definition of molarity. And now the question comes in, why it is a function of temperature? That we'll answer now. The thing is that formula of what is the formula of molarity? That is the next one. So the formula of molarity is the number of moles of solute divided by the volume of the solution in liters. Okay, and now the molarity is weight of the solute divided by gram molecular weight of the solute. This is the formula which you can use straight away. This weight of the solute divided by gram molecular weight of solute. Gram molecular weight of solute accounts for the number of moles of solute multiplied by 1000 divided by VML. This is how you can do. The number of moles of solute is given by the weight of the solute divided by gram molecular weight of solute. And molarity varies with temperature due to change in the volume of the solution. Why the volume of the solution? Volume changes with the temperature and hence the molarity changes with temperature. You can see in the equation that the molarity equation, it contains the volume, right? So as the volume changes with temperature, molarity changes with temperature. That is the idea here. So the next one is what is the unit of molarity? That is gram mole per liter. That's how you can write, or you can write moles per liter. And 1 liter is 1 decimeter cube. This is the one which you have to remember. And now we have a small problem here. What is the calculate the molarity of sodium hydroxide solution given that 10 grams of sodium hydroxide is dissolved in 1 liter or 1 decimeter cube of solution. And given that what is the weight of sodium hydroxide, that is 10 grams, and the molecular weight of sodium hydroxide is, you can add up, that's 23 for sodium, 16 for oxygen, and 1 for hydrogen. And so it accounts for 40 gram per mole. So that's the molecular weight. Always remember the molecular weight is expressed in gram per mole. And so the molarity calculation goes like this: weight of NaOH divided by gram molecular weight of NaOH multiplied by 1000 divided by VML. So 10 by 40 multiplied by 1000 divided by 1000. So 1000 ml, right? So we have plugged in the numbers. So which works out to be 0.25 molar, or you can say 0.25 moles per liter, or 0.25 mole liter inverse. So this is how you can express. The next one is the calculate the molarity of 30 grams of cobalt nitrate 6H2O, CONO3 twice 6H2O in 4.3 liters of solution. So in this box I have written how to calculate the molecular weight of the cobalt nitrate 6H2O. The cobalt accounts for 58.7 plus 2 times 14 for that of nitrogen, and oxygen is like 16. So I'll slightly zoom this and then you can see, so that you can see this clearly. So here you go. So this is accounts for so 14 for that of nitrogen, and then 3 times 16 is for the oxygen, and twice the 2 is for twice. Okay, and 6H2O 6 times 18 for that of water, 2 into 1 for hydrogen, and 16 for oxygen, and which sums up to 58.7 plus 124 plus 108, it sums up to 290.7 gram mole inverse. So that's the molecular weight calculation. And molarity is weight by gram molecular weight and multiplied by 1000 by VML. So 30 grams is the cobalt nitrate 6H2O which is dissolved. 30 divided by molecular weight of cobalt nitrate, and 1000 by 4300 ml. Okay. So or you can directly write that 4.3 liters at the bottom without 1000 on the top. That way also you can write. So this accounts for 0.103 accounts for the number of moles divided by 4.3 liters, 4.3. Okay, So this works out to be 0.024 molar, or you can write 0.024 moles per liter, mole liter inverse. Okay. Next, let us see the another question. This is called a dilution equation based question. Given that 30 ml of 0.5 molar H2SO4 and it is diluted to 500 ml, calculate the molarity of H2SO4 after dilution. And this is a question, and how to do this question. This is based on something called dilution equation. Dilution equation is V1M1 is equal to V2M2. That is initial volume multiplied by initial molarity is equal to final volume multiplied by final molarity. So initial molarity is 0.5. Okay, 0.5 molar, and that initial volume is about 30 ml, and M2 is what we have to calculate final molarity, and multiplied by the final dilution volume is about 500 ml. So 500 we have plugged in, and let's see that M2 is nothing but 500. You transport this side, you get 0.03 molar. So that's how the calculation goes. Now the next one is define molality. So molarity is different from molality. So that is number of moles of solute per kg of solvent. So that is the definition, and it is independent of temperature because mass will not vary with temperature, but whereas volume varies with temperature. So hence the reason the molality does not depend upon temperature. Now, molality is number of moles of solute divided by mass of the solvent in kg, or you can write it as number of moles of solute. You can write it as weight by gram molecular weight into 1 by mass of the solvent in kg. Now, let us see the question here based on the molality. This was asked many times, and it was asked in foreign 2012, 2008, and NCERT also in once or twice in the MSET examination, Andhra Pradesh. So let us see this question. If the density of a lake water is 1.25 gram per ml and it contains 9.2 grams of Na plus ions, sodium plus ions per kg of water, calculate the molality of Na plus ions in the lake. So that is the question here. And how to do this? Molality, the formula is weight by gram molecular weight into 1 by mass of the solvent in kg. What is given in the question is that weight of the solute per kg of the solvent. They have already given this part, that is 92 gram per kg. This they have already given to us. And now that is weight of the solute, that is sodium plus ions per kg of water. They have already given, that is 92 gram per kg. This is already given. So what is given in the formula? Let us see. So this formula, what is actually given is that you can see this. I will round off what is exactly given. So it works out to be this one. So this is the entire thing what is already given to you. Okay. So weight by mass of the solvent per kg, that is within this trapezium thing that is already given to you. And now this, if you divide this entire thing with the gram molecular weight, you got the molality. So that is the idea over here. So let us see this one. So the molality is weight of solute per kg of solvent divided by gram molecular weight. So weight of solute per kg of solvent, that is already given 92 gram per kg. What is there? What I have shown you in trapezium, that part is 92 gram per kg. And again, gram molecular weight of solute, that is atomic weight of sodium plus ions, which is 23 gram per mole. That we are dividing, and 23 fourths is 92. So that accounts for 4 moles per kg. So that is the molality of the sodium plus ions within the lake water. Okay, so hence the calculation, and that's it for this video. And that's the end of the video. So that's the end for you. Okay, this is the end of the video, and thank you all. Thanks for watching the video, and let's meet in the next lecture.